Okay, in this video, we're going to be talking about section 3.3, dealing with dividing polynomials and remainder and factor theorems. And in this section, we're going to be talking about how to use long division to divide polynomials. Also, we'll use synthetic division to divide polynomials. Also, evaluate a polynomial using the remainder theorem and use the factor theorem to solve a polynomial equation. All right, so the first thing we're going to talk about is how to use long division and the division algorithm, okay? Now, in long division, this has the repetitive procedure that we use here. Number one, we divide and then multiply, then subtract, and then bring down the next term, okay? Now, I'm going to bring up a simple division problem that you probably have learned in math a long time ago in elementary school, like 719 divided by 47. Okay. Of course, we know 719 is going to be the dividend, the divisor is the 47. And the answer that we get will be the quotient and remainder. So if I was to divide 47 into 719, I would try to do this. I know 47 can't go into 7, but I know 47 can go into 71 one time. That's dividing. And then do 1 times 47, which would be 47. And then subtract 47 from 71, you'll get 24. And then you bring down the next term. And we continue that process until we're not able to divide, or if the remainder is less than your divisor. So here, 47 into 249 would go, in this case, 5 times. And then 5 times 47, this will be 235. And then finally subtract 235 from 249, you'll get 14. And here, this number is less than the divisor, meaning 47 can't go into 14. So in this case here, I do have 14 as a remainder. So 47, well, 719 divided by 47 would be 15 with a remainder of 4. That's using long division with just whole numbers. In this case, we're going to use that concept with polynomial division using long division. So here is the procedure for that. Number one, you want to arrange the terms of both the dividend and the divisor in descending powers of the variable. And then number two, divide the first term in the dividend by the first term of the divisor. And that result will be the first term of the quotient. And then you're going to multiply every term in the divisor by the first term in the quotient. And then you're going to write the resulting product beneath the dividend with like terms lined up. And then you're going to subtract that product from the dividend. And then bring down the next term in the original dividend and write it next to the remainder to form a new dividend. And then you're going to use this new expression as the dividend and repeat this process until the remainder can no longer be divided. This will occur when the degree or the highest exponent of the remainder is less than the degree or the highest exponent of the divisor. All right, so an example like this. All right, let's say we had something like this. We want to divide x squared plus 14x plus 45 by x plus 9. And that's using long division. All right, so the way I set this problem up will be this. The x plus 9 is your divisor. The x squared plus 14x plus 45 is your dividend. All right, so notice that the terms on both the dividend and the divisor are in descending powers. So the next step will be to divide the first term of the dividend, which is in this case your x squared. I'm going to do this off to the side. That's going to be divided by the first term of the divisor. That's going to be x. So x squared divided by x would just simply be x. Now that x will be in the quotient. And notice I'm putting the x above 14x. I'm lining up all my like terms here. And then I'm going to multiply this times the divisor. Each term in the divisor will be multiplied by x. So when I do x times x, that's x squared. And then x times that plus 9 will be plus 9x. And then we're going to subtract the product from the dividend. Now, the way I'm going to subtract is to change the sign of each and every term to the opposite. So x squared becomes negative and 9x becomes negative as well. And then combine like terms here. The x squared minus x squared, that's gone. And then 14x plus negative 9x, or you can say 14x minus 9x will be 5x. And then we bring down the next term, which is that plus 45. And then we're going to repeat that process. So here, I'm going to take the first term of what's left, divide that by the first term of your divisor. So here I'm going to do 5x divided by x. Well, 5x divided by x would just be 5. And it's a plus 5, so I put plus 5 in the quotient. And then I'm going to multiply that 5 times the x plus 9. So 5 times x will be 5x. And then plus 9 times 5 would be 45. And then I'm going to subtract. I'm going to do that by changing the sign of each and every term to the opposite. So you can see here the 5x minus 5x, that's gone. 45 minus 45, that's gone. I have a remainder of 0. Okay. So here, when I divide x squared plus 14x plus 45 by x plus 9, I would get a quotient of just simply x plus 5. And here in this case, I got a 0 remainder. Okay. All right, next we'll look at the division algorithm. Okay. Now we're still going to be doing the long division for now, but let's talk about this division algorithm. It says here if f of x and d of x are polynomials with d of x not equal to 0 and the degree of d of x is less than or equal to the degree of f of x, then there exists a unique polynomial. There exists unique polynomials q of x and r of x such that f of x will be equal to d of x times q of x plus r of x. What that is this. Your f of x is the dividend. The d of x is your divisor. Q of x is the quotient. And r of x is the remainder. So to get the dividend, you just take the divisor, multiply by the quotient, and then add the remainder. That will give you your dividend. Now the remainder r of x equals 0, or it is a degree less than the degree of d of x. If r of x equal to 0, then that means we say that d of x, which is your divisor, divides evenly into f of x, and that d of x and q of x are factors of f of x. So in that last example that I just did, here I got a remainder of 0. So I can say here that x plus 5 and x plus 9 are considered to be factors of x squared plus 14x plus 45. Because this dividend divides evenly. Or I should say, this x plus 9 divides evenly into the x squared plus 14x plus 45. Okay, so that's what the division algorithm is. Okay, now let's look at some examples like example 2. We're still doing long division here, so here we're going to divide 7 minus 11x minus 3x squared plus 2x cubed by x minus 30. And we want to express the result in the form of a quotient plus remainder divided by the divisor. Okay, so now the first thing I see here is this, that x minus 3, that's in descending powers. So here, that will be my divisor. And this is the dividend right here. I need to put this in descending powers first. So that means I need to put the 2x cubed in front. And then minus 3x squared is after that. And then minus 11x. And that 7 is a positive, so that means plus 7. Okay, so the dividend I had to put in descending powers from the highest exponent to the constant term. Okay, so now we're going to divide the first term of the dividend by the first term of your divisor. Here, 2x cubed divided by x. So I'm going to write this off to the side, 2x cubed divided by x. When I take 2x cubed and divide that by x, I'm going to get 2x squared. So that 2x squared goes here in the dividend, in the not the divisor, the quotient. And then I'm going to multiply that 2x squared times each term in the divisor. So if I do 2x squared times x, that's 2x cubed. 2x squared times the minus 3 would be a minus 6x squared. And then we subtract by changing the sign of each and every term. So this 2x cubed becomes minus, the minus 6x squared becomes a plus. And then we simplify here. That 2x cubed minus 2x cubed, that's gone. Minus 3x squared plus 6x squared will be a positive 3x squared. Okay, and then next we bring down the next term, which is in this case minus 11x. And then repeat that process here by doing the first term in this expression, the 3x squared, divide that by the first term in your divisor, which is x. So here this will be 3x squared divided by x. And when I do 3x squared divided by x, that's going to be 3x. And that 3x will go in the quotient as plus 3x. Then I'm going to multiply that 3x times x minus 3. When I do 3x times x, that's 3x squared. 3x times minus 3 will be a minus 9x. And I will subtract by changing the sign of each term here. The 3x squared becomes minus, the minus 9x will be plus 9x. And then we'll combine those two. Well, that 3x squared minus 3x squared, that's gone. Negative 11x plus 9x will end up being negative 2x. And then we bring down the next term, which is plus 7. So I'll be dealing with negative 2x plus 7. Well, the first term in that expression, I'll take that and divide that by the first term in the divisor. So negative 2x will be divided by x, which would be minus 2 or negative 2. So that means that negative 2 will go into the quotient as minus 2. Now, minus 2 would be multiplied by my divisor of x minus 3. So if I do minus 2 times x, this will be negative 2x. And then minus 2 times minus 3 will be a plus 6. All right, so here we're going to subtract by changing the sign to the opposite. Minus 2x will become plus 2x. The plus 6 becomes negative. So negative 2x and plus 2x is gone. 7 plus negative 6, or 7 minus 6, will be 1. Now that would be as far as I can go with that problem. So in this case here, that 1 that I have here will be the remainder. Okay, so I'm going to have 2x squared plus 3x minus 2, and then that's going to be plus the remainder of 1. It will be divided by what my divisor is, x minus 3, because it's always remainder over the divisor. So this will be the final answer to 7 minus 11x minus 3x squared plus 2x cubed divided by x minus 3 would be 2x squared plus 3x minus 2 plus 1 over x minus 3. Okay. All right, now let's say we want to do long division, but in long division, sometimes you may have terms that are missing. So in this case here, if a power of x is missing in either the dividend or the divisor, add that power of x with a coefficient of 0 and then divide. This way, like terms will be aligned as you carry out the long division. Okay, so in this example, we got 2x to the 4th plus 3x cubed minus 7x minus 10. We want to divide that by x squared minus 2x. Well, I see my divisor is x squared minus 2x. But let's take a look at that dividend that we have here. We got the x to the 4th, we got x cubed. But we're going from x cubed to x. That means we are missing an x squared term. So the way we're going to write this dividend would be this. We got 2x to the 4th plus the 3x cubed. We're missing the x squared term. So we have to add or compensate that with 0x squared. And then minus 7x minus 10. Okay, so now we're ready to divide by taking the first term of the dividend, divide that by the first term of your divisor. The 2x to the 4th will be divided by x squared. So 2x to the 4th divided by x squared, that's going to be 2x squared. And that 2x squared would go in the quotient. And notice that I'm aligning these like terms here. Where I got 0x squared here. I'm putting the 2x squared above it. So here 2x squared will be multiplied by the divisor of x squared minus 2x. So here 2x squared divided by x squared will be 2x to the 4th. And then 2x squared times minus 2x would be a minus 4x cubed. So here we're going to subtract by changing the sign of each term. So that 2x to the fourth would be negative, minus 4x cubed would be plus. So in this case here, 2x to the fourth minus 2x to the fourth, that's gone. And then 3x cubed plus 4x cubed would be 7x cubed. Then I bring down the next term, which is at plus 0x squared. And now we repeat the process here. Take the first term of this expression, which is 7x cubed, divide that by the first term of your divisor, which is x squared. So we got 7x cubed divided by x squared. Well, 7x cubed divided by x squared would just be 7x. And it's a plus 7x, so we have to put plus 7x in the quotient. And now we multiply that 7x by your divisor. So 7x times x squared, that's 7x cubed. 7x times minus 2x will be a minus 14x squared. And then we subtract by changing the sign. So this will be minus 7x cubed, and this will be plus 14x squared. So 7x cubed and a minus 7x cubed, that's gone. 0x squared plus 14x squared will be 14x squared. And then we bring down the next term, minus 7x. And now we take the first term of this expression, that's 14x squared. Divide that by the first term of your divisor, x squared. Okay, so 14x squared divided by x squared would be 14. And that 14 will go in the quotient as plus 14. And I multiply that 14 times whatever my divisor is. 14 times x squared is 14x squared. And then 14 times minus 2x will be minus 28x. And then we subtract by changing the sign to the opposite. So that 14x squared becomes negative, minus 28x becomes plus. That way, 14x squared minus 14x squared is gone. Negative 7x plus 28x would be 21x. Then I bring down the last term, which is a minus 10. Now notice I can stop right here because the highest exponent here is less than the highest exponent in the divisor. So 21x minus 10 would be my remainder. So I'm going to have 2x squared plus 7x plus 14, and then I'm going to add that remainder of 21x minus 10 all over the divisor x squared minus 2x. And this quotient and the remainder is the final answer. Okay. All right, now let's look at a quicker way to divide polynomials. And that's going to be using synthetic division. Here we're going to use synthetic division to divide polynomials. And we can only do that if your divisor is of the form x minus c, where c is a constant. This method of synthetic division provides a quotient more quickly than long division. Okay, and in the blue box on your handout, this is the procedure for doing synthetic division. Okay. To divide a polynomial by x minus c. And let's say we had this example, x cubed plus 4x squared minus 5x plus 5 divided by x minus 30. The first step would be to arrange the polynomials in descending powers with a zero coefficient for any missing term. And in this case, these powers are in descending order from the highest to the constant term, both in the dividend and in the divisor. And there are no missing terms. We have x cubed, x squared, the x, and the constant. Now you're going to write the c for your divisor of x minus c on the left side, okay? Now to get your divisor, if you have x minus c, the best way to do that is set that expression equal to 0 and get x by itself. That will tell you what the divisor is going to be in synthetic division. So in this case here, I would take that x minus 3, which is my divisor, and set that equal to 0. Solve for x, you'll get x is equal to 3. That will be the divisor here. And then you're going to write the coefficients of the dividend. Like for x cubed, that coefficient is the understood 1. For x squared is 4. For x is negative 5. And the constant is 5. That's step number 2. Now step number 3 is to write the leading coefficient of the dividend on the bottom row. So here you bring down that 1 in this case. That's your leading coefficient of the dividend. That goes on the bottom row. And then step number 4, you're going to multiply your c, which is your divisor, by the value that was written in that bottom row. And then write the product in the next column in the second row. So in this case, if I multiply that divisor 3 times the 1 on the bottom, I will get 3. That 3 goes underneath the 4 in the next column. And then you're going to add those values in the new column. That's step 5. So it would be 4 plus 3, which is 7. And then you're going to repeat this series of multiplications and divisions until all the columns are filled in. So in this case, after we add 4 and 3, we get 7. Now you're going to multiply the divisor of 3 times the 7. That's going to give you 21. That 21 goes underneath the negative 5. And then add negative 5 and 21 together, you'll get 16. And then finally, you'll do 3 times 16. That's 48. That 48 goes underneath the 5. Add 5 and 48 together, you'll get 53. So here all the columns are complete. Now, step number 7 is very important because you're going to use the numbers in the last row to write the quotient plus the remainder above the divisor. The degree of the first term of the quotient will always be one exponent less than the degree of the first term of your dividend. The final value in that row is the remainder. So in other words, that 53, that's all, that last number in the last row is your remainder. So 53 becomes your remainder. The 1, the 7, and the 16 are your numbers for the quotient. And the quotient is always going to be one exponent less than the highest exponent in the dividend. The dividend started off as x cubed. So your quotient will be starting off as x squared. So you have 1x squared and then plus 7x plus 16. And your remainder of 53 will be over your divisor. So it'll be 53 over x minus 3. Okay, so now let's look at the next page. You're going to see the difference between the long division and the synthetic division. Here we got the same problem. that I went over with you. Here they use the long division. This is, on the right, is the synthetic division that they use. And it's that same problem that I went over with you in that example. Okay, so now let's do a few of these, like in example 4. Here we're going to use synthetic division to divide 5x cubed minus 6x squared plus 3x plus 11 by x minus 2. Okay, so let's set up our synthetic division. The divisor is going to be the x minus 2. What I'm going to do here is set that equal to 0 to find out what divisor I will use in synthetic division. So for x minus 2 is equal to 0, if I add 2, you'll get x is equal to 2. So my 2 is the divisor. Now, here, that 5x cubed minus 6x squared plus 3x plus 11, that's the dividend. There are no missing terms. I have x cubed, x squared, x, and the constant. So I can write their numerical coefficients. So for the 5x cubed, that coefficient is 5. For minus 6x squared, that coefficient is negative 6. For 3x, that coefficient is 3. And the constant term is 11. And notice I'm drawing a little bitty box here. That's to separate the quotient from the remainder. So here is how I do the synthetic division. We bring down the first term, or the leading coefficient in the bottom row, which is 5. So I bring that down first. And then I'm going to multiply, in this case, the divisor of 2 by that number in the bottom row. So this will be 2 times 5, which is 10. And that 10 goes here. That 10 goes underneath the negative 6. Not underneath the 5, this negative 6. Okay. And if this helps, if you draw arrows there, like this, like I did here, you'll be avoiding placing the wrong number underneath the wrong column. And then next I'm going to add negative 6 and 10 together. You add those two. This will give me 4. And then we're going to repeat that process until all the columns are filled. So in this case here, we take the divisor of 2, multiply it by this number, the 4. So if I do 2 times that 4, I'll get 8. That 8 will go underneath the 3. And then I'm going to add 3 and 8 together to get 11. And then finally, take the 2, which is my divisor, multiply it by this 11. 2 times 11, that will be 22. That 22 goes here. And then I'm going to add 11 and 22 together to get 33. And I'm done with that problem. So now, that 33, which is the number inside that box, that is the remainder. So the last number in the last row is always your remainder. The 5, the 4, and the 11 will be your quotient. I'm going to show you how to write that quotient. Since that 33 is your remainder, this 11 will be the constant term. The number in front of that will be the coefficient of x. The number in front of that would be the coefficient of x squared, and so on. If there was another number in front of that, it would be the coefficient of x cubed. But here the 11 is the constant term. That 4 is the coefficient of x. This 5 is the coefficient of x squared. So the way I write the quotient and the remainder is going to be this. 5x squared, and then plus 4x plus 11. And then the remainder will be written over the divisor, 33 over my divisor of x minus 2. And this will be your answer, the quotient and remainder. Okay. All right, here's another example. Let's say I want to use synthetic division to divide x squared by x cubed minus 7x minus 6 by x plus 2. All right, so in this case here, I need to know what my divisor is going to be in synthetic division. So I'm taking that x plus 2, set it equal to 0. And solve for x by subtracting 2. That would mean x is equal to negative 2. So negative 2 would be the divisor. And here's my dividend, x cubed minus 7x minus 6. Let's take a look at this for a moment here. There's a term that's missing here. I'm going from x cubed down to 7x. So that means x squared is missing. Now, if this helps, the highest exponent, of course, is x cubed. And then we go to x squared, and then x, and the constant term. So I'm going to need a 0 coefficient for the x squared term. Because here, x cubed, its coefficient is the understood 1. There is no x squared term, so I need a 0 here. The coefficient of x is negative 7, and the constant term, negative 6. Okay, so I'm ready to do my synthetic division. I'm going to bring down the leading coefficient of 1 in the bottom row. And then I would do the divisor times the number in the bottom row, negative 2 times 1. That would be negative 2, and that goes underneath the 0. And then I'm going to do 0 plus negative 2. That's negative 2. And then next, I will do my divisor of negative 2 times this number, negative 2 times 2. Negative 2 times negative 2, I mean, that's 4. And that should be positive 4. Then I'm going to add negative 7 plus 4 together. This will be negative 3. And then finally, negative 2, which is my divisor, times that negative 3. So negative 2 times negative 3 will just be 6. Then we add 6 and negative 6 together. You'll get a remainder of 0. So that 0, which is the last number in the last row, is your remainder. The 1, negative 2, and negative 3 are the terms that will represent the quotient. Okay. Now here, the negative 3 will be the constant term. The number in front of that, which is your negative 2, that will be the coefficient of x. The 1 in front of that would be the coefficient of x squared. So here my quotient, in this case, will be 1x squared, or just x squared, minus 2x minus 3. And we don't need to write 0 over the remainder of x plus 2. Okay? And I do need to mention something here. In the My Math Lab homework, they're going to ask for the quotient and the remainder. So that x squared minus 2x minus 3, that is the quotient. And the remainder is just going to be right here. Just going to be 0. And then that last example that I did, this part right here, you'll enter that part as the quotient, and then you'll just enter the number above the x minus 2 of 33. That will be your remainder, and not 33 over x. minus 2. You won't enter that whole thing in my math lab. They just want the number that represents the remainder. Okay. All right, now let's talk about how to use the synthetic division with the remainder theorem. And the remainder theorem states that if a polynomial called f of x is divided by x minus some constant, then the remainder is going to be f of whatever that constant is. So here, this is just another way of evaluating a function at a given x value. All right, so in example 6, we're going to use the remainder theorem to find f of 3. And in this case, our f of x function is x cubed minus 7x squared plus 5x minus 6. All right, so here, that x is f of 3 means that x is equal to 3. That's going to be your divisor. And this f of x function represents your dividend. Notice that there are no missing terms. We do have x cubed, we have x squared, the x term, and the constant. So we can write their numerical coefficients here. That x cubed has a coefficient of 1. The x squared has a coefficient of -7. The x has a coefficient of 5, and the constant term, -6. And I'm drawing the box to separate the quotient from the remainder. So let's bring down the leading coefficient of 1 in on the bottom row and multiply that by our divisor. 3 times 1, that's going to be 3. So the 3 goes underneath the -7. And then we add -7 plus 3. That's -4. And then we repeat that process. Do 3 times -4. That's -12. Add 5 and -12 together, you'll get -7. And then finally, 3 times -7 would be -21. And then add -6 and 21 together, you'll get -27. Okay, so this number that's in the box, that's the last number in the last row. That is your remainder. And not only that, that remainder represents the value of the function when x is equal to 3. So here, we can say here that f of 3 equals -27. And in this case here, you can substitute x with 3 into that function. You'll find out that you will get -27 as an answer. But here, using the factor theorem and using synthetic division, you can find out what the value of that function is at the given x value using this approach. All right, here's another example. Let's say we are given f of x is equal to 3x cubed plus 4x squared minus 5x plus 3. And we want to use the remainder theorem along with the synthetic division to find f of -4. So here our x is -4. That means -4 would be our divisor. And that f of x function is going to be our dividend. There are no missing terms. We have x cubed, x squared, the x, and the constant. So I can write the numerical coefficients here. For x cubed, that coefficient is 3. For x squared, it's going to be 4. For the x, -5, and the constant term would be 3. And that box represents the remainder. Now we're going to bring down the leading coefficient in the bottom row, which is 3. And then we're going to multiply -4 times 3, which is -12. Then I'm going to add 4 and -12 together to get -8. And then we'll do -4 times -8. That would be 32. That goes underneath that -5. -5 plus 32 will be 27. And then finally, -4 times 27. That would be -108. Add 3 and -108 together, you'll get -105. So here, that last number in the last row, that is your remainder. Not only that, that remainder represents the value of the function, of this function, when x is equal to 4. So in this case, f of -4 is equal to -105. Right. Finally, we'll look at the factor theorem. Let's say you're given a polynomial f of x. Here, if f of c is equal to 0, then that means that x minus c will be a factor of the function f of x. And the other part is just a converse of part A. If x minus c is a factor of f of x, then that means f of that constant c equals 0. Okay. All right, so now we got a couple of examples that we're going to look at using the factor theorem. Let's say we want to solve the equation 2x cubed minus 5x squared plus x plus 2 equal to 0. And we're given that 2 is a 0 of the function f of x equal to 2x cubed minus 5x squared plus x plus 2. Okay. Well, if 2 is a 0 of that function, that means f of 2 has to be equal to 0. And if f of 2 is equal to 0 based on the factor theorem, x minus that constant c, and the constant here is going to be 2, so it'll be x minus 2, is a factor of f of x. Has to be. Because f of 2 is equal to 0. So x minus c, and c is going to be 2. So x minus 2 will be a factor of this function f of x. Now let's find out what that other factor is going to be by synthetic division. So here, 2 is a 0. So that means that 2 will be your divisor. And if you look at f of x, which is 2x cubed minus 5x squared plus x plus 2, there are no missing terms here. I have x cubed, I got x squared, the x, and the constant. So I can write their numerical coefficients. For 2x cubed, that will be 2. For the x squared, the coefficient is -5. For the x is 1. Constant term is 2. So here's where the synthetic division comes in. Bring down the leading coefficient in the bottom row, that's the 2. And then we multiply that number times our divisor. So 2 times 2 would be 4. That goes underneath the -5. Add -5 and 4 together, you'll get -1. And then multiply 2 times -1. That'd be -2. Add 1 and -2 together, you'll get -1. And then finally, 2 times -1 will be -2. Add 2 and -2 together, you get 0. And I would expect to get a remainder of 0 because I know that x minus 2 is a factor of the function. So this part right here where I got 2 minus 1, well, 2 -1 and -1, that's the quotient. This -1 will be the constant term. The -1 in front of that will be the coefficient of x. The 2 in front of that is your coefficient of x squared. Okay, so let me write this out as 2x cubed plus, no, not plus, minus 2x cubed minus 5x squared plus x plus 2 equal to 0. I know x minus 2 is a factor, so that's going to be the x minus 2. I'll write that down. But this right here, the quotient, that's the other factor of this. So that's 2x squared minus 1x, so just x, and then minus 1. That's equal to 0. So if you were to multiply all this out and combine like terms, you'll get this. Now that 2x squared minus x minus 1 can be factored into 2 binomials here. Let's bring down the x plus 2 and factor that quadratic expression into 2 binomials. I'm going to break 2x squared as 2x and x. So I know I'm going to have -1 and a +1, but I got to put those in a way so that the outer and the inner will give me the middle term of a minus x. So if I put -1 here where that x is, and the +1 here, minus 2x and a 1x will give me -x. So factor completely, I get x minus 2 times 2x plus 1 times x minus 1 equal to 0. And now I'm going to set each individual binomial factor to be equal to 0. So this means x minus 2 is equal to 0, and then 2x plus 1 equal to 0, and x minus 1 equal to 0. So here, x minus 2 equal to 0. I'm going to solve for x. That means x is equal to 2. Then for the 2x plus 1 equal to 0, if I subtract 1, I'm going to get 2x equals -1. Divide both sides by 2. This will be x is equal to -1/2. And then for x minus 1 is equal to 0, that means x is equal to 1. So these are all the solutions for that function f of x. That'd be 2, -1/2, and 1. Okay. All right, here's the last example, example 9. Here we're going to solve the equation 15x cubed plus 14x squared minus 3x minus 2 equal to 0. We're given that -1 is a 0 of f of x is equal to 15x cubed plus 14x squared minus 3x minus 2. All right, and we know that -1 is a 0 of that function. That means f of -1 must be equal to 0. And if f of -1 is equal to 0, that means x minus that constant, and here that constant is going to be -1, which means x minus -1, and of course, minus a -1 will be a +1. That means x plus 1 is a factor of your function f of x. So to find the other factor, we use synthetic division. So in this case, that -1 is a 0 of this function. That means -1 will be my divisor. And in this case here, for the 15x cubed plus 14x squared minus 3x minus 2, there are no missing terms. I have the x cubed, its coefficient is 15. I have the x squared, that coefficient there is 14. I have the x, that's -3, and my constant term, -2. So now I'm going to bring down the leading coefficient in the bottom row. That's 15. Now we need to multiply the divisor times the number in the bottom row. -1 times 15 will be -15. And then add 14 and 15 together, you'll get -1. And then -1 times that -1 will be +1. -3 plus 1 will be -2. And then finally, -1 times the -2 would be +2. -2 plus 2, that's 0. Which I would expect to get because I know that -1 is a 0 of the given function. All right, so this part right here is the other factor of f of x. So in this case here, my -2 will be the constant term. The -1 in front of that is the coefficient of x. The 15 in front of that would be the coefficient of x squared. So here, let me write this out as 15x cubed plus 14x squared minus 3x minus 2 equal to 0. One of the factors is x plus 1, so I'll write that down. And the other factor of the function is right here. That's 15x squared minus 1x, so just x, minus 2 equal to 0. Now that 15x squared minus x minus 2, I'm going to try to factor that out into two binomials here. So I'm going to bring down the x plus 1. Let's see here. That 15x squared, I'm going to break that up as 5x and 3x. I'm using that because if I try 15x and just x, I'm not going to be able to come up with a factor of -2 where the outer and the inner will be minus 1x. So 5x and 3x would work best. The only factors of 2 would be 2 and 1. So I'm going to put the -2 here and the +1 here, where 5x and a minus 6x will give me minus 1x. So that's x plus 1 times 5x minus 2 times 3x plus 1 equal to 0. Then set each binomial factor equal to 0. So this will be x plus 1 equal to 0, 5x minus 2 equals 0, 3x plus 1 equal 0. And each equation will solve for x. So for the x plus 1 equal to 0, well, if I subtract 1, that's x is equal to -1. But 5x minus 2 is equal to 0. If I add 2, you're going to get 5x is equal to 2. Divide by 5. That means x is equal to 2/5. And then for the 3x plus 1 equal to 0. We subtract 1, you'll get 3x is equal to -1. Divide both sides by 3. X is equal to -1/3. Okay. So these are all the zeros of that particular function here. That's going to be -1, 2/5, -1/3. Okay. Okay. Now with that factoring of 15x squared minus x minus 2, I use the trial and error method. There's also the AC method where you multiply the coefficient of the x squared term times the constant term. And then that product, you'll have to find factors of that product that would give you the middle term of negative x and go from there. Again, if your factoring skills are not up to where it needs to be, there are YouTube videos out there that will help you with methods of factoring. Okay. So that concludes this video on section 3.3, dealing with dividing polynomials and using the remainder and factor theorems. Do feel free to email me if you have any questions about the homework in my math lab, or if you have questions about any of the examples that are presented in this video.